Hello everyone and welcome. In this episode, I'm going to be continuing what we started the last time with respect to the flowcharts and the gdl.hpp file. We're gonna continue from where we left at generate complex flowcharts. So complex goal charts, and let's get started. So last time we stopped at generate simple goal chart, and now let's just explore generate complex flow charts. As well, I'm just gonna take what I started here. And so what's so special about this function? It just takes additional arguments. So we can control the range mainly and recursion depths. Okay, so let's call it and adjust the arguments. So the file name, weight title, the actual title of the function. Now the range. Just for the sake of demonstration, I'm going to just give it the range of main, although I can give it min EA and max EA as well. Let's do it for main for now. So f equals, let's get the function object. Okay, so here f dot start EA. Okay, so we pass those. Recursion level is optional. I'm gonna leave it like this. So let's, if I run it like this, it will give me an error, and we'll see, we'll explain this. So that's not enough really to tell it how to generate. So here it says cannot find any xrefs. Because we have to tell it, for example, what kind of complex call chart we want. Let's see, references to the addresses. Okay, so here not much, I guess, but let's explore the two flags. So referencing for that function, let's see how that works. So that's basically what references the range we're talking about. So here we have, that's it, from the entry point, C runtime, helper function, library function, and main. So let's switch it to referenced. What is referenced from this? Also, we can combine the flags, all right? But for now, just to simplify the graph. So here we are gonna display the call graph and the range, what is referenced from within that range. So hopefully we should see all the outgoing stuff happening within the range. So let's take a look. So this is our main, and we can see all the referenced stuff like functions that are being called, strings, imports. And because we did specify a recursion, we are seeing also the children and what they are referencing. So let's try to control the recursion and specify just one level and see how the difference would be. So here, for example, just one level referencing. And that could be useful if we just want to see quickly what main directly does, for example, or what main references. Let's try to combine who references this as well at the same time. Let's see if they work together. And run. So we should see main not necessarily the only top node here because of also recursion, one level recursion. That's what references main at one level. Now if we increase it by, let's say, 2, we should see start as well. So let's and let's see, here we have start and so on. So, and of course we said main, we specified recursion, we specified what it references, what's referencing, both flags, so we will see everything in both directions as well per recursion level. And similarly, We don't have to generate a GDL file. If you want to use dot, we could have done the same. So let's just check it out in dot and repeat the same command. And here this is nicer. If you work with dot, you can post-process that file, maybe change the syntax, change the layout, and so on. So now we're gonna be talking about QFlowChart class. So QFlowChart inherits from cancelable graph. Cancelable graph inherits from GDL graph, which we spoke about quickly the last time. In essence, from that we can get the size or node quantity, entry, which is always gonna be 0, and exit, we could have multiple exit points, and as well like number of successors for a given node, number of predecessors for a given node, and then given a node, and we start enumerating from 0 to number of successors. We're asking, give me the successor for node, and at first one, second one, and so on. Each time we get the node ID. These are the most important functionality in the GDL graph. So cancelable graph, on the other hand, adds one more method, check if cancel is clicked. So this is up to the implementer. We're not gonna be actually talking what happens behind the scenes. Before we talk about basic block, let's go back to the flowchart. So that's what we'll be working with. So the flowchart, either for a function or a set of address ranges. For this video, we're gonna continue just for functions. Here we have an array, or we define blocks underscore t, which is simply a vector of basic blocks. And so now let's take a look at basic blocks, and it's basically accessible through the blocks. So blocks is an array of basic block. What is a basic block? A basic block inherits from range. That means it has a start and end EA. And then it has, for each block, we have a vector of successors, int vectors, which means every successor is simply an ID. Same for predecessors, so as well. So once we get the basic block, we get its range, start and end EA, and then we can ask about the IDs of successors and predecessors. Same story for a flowchart. We have a title that if it's gonna go to a file and so on. Bounds. So when we create the flowchart, specify the title, function name, or the range, which this range is really passed to the bounds constructor, which we're constructing. And the flags. Flags are one of the fc underscore flags, which are defined here. Fc print, don't compute external blocks. This used to be compute predecessors. Now it's by default, and to disable predecessor computation, we specify the no preds. We can change the way the flowcharts or the basic blocks are computed. If we say flowchart call ends, that means every basic block will not terminate on, let's say, a return or a conditional and so on. A call instruction will also break the block. If we pass this flag and the computation is still happening, we may get a dialog where we can cancel the computation. So these are the flags. Let's test it out, and QFlowchart T. And start, okay, so we need the title, function pointer, no range, and the flags. Since the flags really, I want predecessors, I want the default behavior, nothing really to touch on the flags, it's gonna be 0. All right, so title is, again, some title. Function, we're gonna use the current function. Let's just add some variability here. Instead of using IDC, I'm gonna use the lower level function. And ranges, we don't need the ranges. Flags, we're gonna pass 0. Okay. So once we call the constructor, basically, behind the scenes, it will directly compute the graph. So let's just now, if I press spacebar here, by the way, you can see these are all the graphs. These are all the basic blocks. And the way they're computed is they're not really calling it with call ands. As we can see, there is a call instruction, but the basic block did not finish at the call. So if we are to count how many basic blocks by hand, we're gonna get the same result as q dot size. So let's clear the screen. And we have 36 blocks comprising this. Now let's just see all the ranges of the blocks and see what they are. So for this, we have to enumerate all the blocks, for example. Now you can enumerate the blocks in using a recursive algorithm and figure out the relationship, treat it like a tree, for example, and so on. But here I'm gonna just enumerate them in a linear fashion without really caring about predecessors in particular, although we can make a nested loop for that. So let's say for I in range q dot size. So I or ID, let's just call it block ID. So this will give us the block ID. And block IDs are serial from 0 to the size. And so what do we want to do with those, with every ID? We want to get the basic block and display the start and end, basically. That should be a good starting point. So now if you look at the methods, it's not directly evident from the SDK alone how to get an actual block. Well, we might say we have the blocks. So if I say here q.blocks, I will be surprised like we don't have blocks. And the reason for that is we'll have to look at how the flowchart is wrapped. So if we look at gdl.I, we will have our answers. So we have a bunch of ignore directives. We are explicitly ignoring for a basic block, for example, the successors and predecessors. We are ignoring the blocks from the Q flow chart. And then we are extending that. So when we are converting or writing the Python adapter for that C++ class, we are adding a special getItems method, which will return a pointer to the blocks. So we ignore the blocks, and for Python we expose it through the getItem method, which will basically give us like indexing capability. So that means I can, to get the block of a given ID, I will just say Q for the Q chart itself and the block ID. And this will give me a basic block. And as we said, so we get a basic block, and the basic block has the range. And we won't be able to access the successors and predecessors directly because they're ignored. But we will have to use a couple methods instead. So we got the basic block for now, and we can say, let's display a block ID and then the range. So since it extends from range, the block, this is not the first time we talk about range. The most important things in a range are start and end EAs. Start EAX and EAX. All right. Okay. So here, for example, this is the first block. And as we said, if we really wanted like the entry block, we have a helper method q.entry. So this is good for recursivity. I mean, we can start our recursive algorithm from the entry block, and then we can recursively go and follow successors, predecessors, and so on. Now, this function has multiple exit points. So that's an exit point here. This is another one, another one, another one. So in that case, if we say q.exit, it's really meaningless. There are multiple exits, and if you remember that when we looked at the implementation of exit, it just assumes that it's the last block as the exit, which is not necessarily reliable. So this is for each block, for example. Now let's try to identify the block kinds and maybe only display the returned blocks, for example. So for this, from the block itself, we have calculate block type. So we give a block ID and it gives us an FC block type. So let's also take block type, and we can ask the flowchart itself to calculate the block type for the basic block ID we want. Now we have the block type. We can say if block type equals equals, and here, for example, is it a return? Is it a conditional return, and so on? We can check directly for the type, or there's a helper method for that. So we can also use the isRet block, which we give it the type, and it will do that check for us. We have the inverse is no ret block, so we can also now see if this does not return. So for this, I want to use the helper method. So if it is a return block, I'm gonna display return block. And here I have, let's see how many. So we have almost half return blocks. So indeed, this function has multiple return points. So this is the gist of it. Now let's display just for every block the successors and predecessors. Successor ID or index, not in this case. We're gonna enumerate. So see what I mean? In range of q dot number of successors for the given block ID. So now let's get the actual block ID. So if we want the actual successor ID, we can then say, give me the successor of ID and given the index. So for like first successor, second successor, and so on. So this gives us the ID of the successor. Now we need to get the basic block. We can say successor block, basic block equals q dot the ID itself. And now let's print successor. We can display, for example, successor block ID and its ranges. So we got the basic block, start EA, SPB dot and EAX. So let's see how that successors. And here let's make graph view. Okay, we are clearing the screen. Let's test it. I removed the previous printout. So here, let's say block ID and its range. Okay. So here, for example, we have block ID 0, this one. Successor is block ID 1, happens to be just the next one. And another successor is block ID 6, which is this exit point. And indeed, this block itself has successor the entry block. So now let's display the preds. So here pred, and just give me the number of predecessor. Let me see. And q.endpreds. Okay, so endpreds, and for this current block, so for the same block, then predecessor ID, give me the predecessor. For given the index, we get the predecessor basic block, then we get the actual basic block from a basic block ID, and we can display the predecessor ID. So as we said, for example, block 6, one of the predecessors is block 0. Block 0, one of the successors is 6. And these are the two-way relationship between the two. Finally, before we conclude, I'm going to show you a convenient high-level class that is built on top of the QFlowChart. And this is defined as well in the GDL module. It has been a handwritten wrapper, so it's going to be called flowchart. Flowchart really behind the scenes just wraps the QFlowChart and gives us some convenience methods. So it not only wraps flowchart, but also gives us a nice high level, a basic block. So I'm gonna try to replicate the previous example using flowchart. Let's clone this and call it flowchart, the high level one, and look at the construction of a flowchart. So the flowchart, just we give it either a function or the start and end. So we're gonna just give it a function pointer. So it makes things easier. So here, flowchart. It doesn't care about the title. Let's see what title internally it does. Just passes null since we're not gonna generate it to a file or display it. So no need for a title. We gave it a function, and bounds, we're not gonna give it bounds. Flags are 0, so that should be enough. So you can already see this wrapper is gonna make things much simpler. And now we have that, let's call it flowchart, just to distinguish. And the flowchart itself has a get item, so we can actually enumerate it naturally. So instead of ID, directly we can get the basic block from the flowchart object. And now if we want the ID, we can say basic block.id, just because the basic block defines ID, start and end. So really it's way simpler, and you'll notice in a second. So so this loop will change. Let's see how we can change it. I'm gonna continue for a second here just to see if everything is okay. So far just those couple lines, we display the blocks directly. Now let's see here. Okay, so we don't have this, but the block itself has preds and successors, and they are generator methods. So you can see the yield, and so we can directly now get the successor basic block. So you can say successor basic block in the basic block itself dot successor. So successors basically. It's a function, so we're gonna use it like this. So we get the, we don't need to do this anymore. We already have the successor. If we want the ID, successor basic block dot ID. Okay, let's test it. All right, and it's gonna be the same story, way simpler. And that's it. Very simple. So really, if we compare how convenient this is, so very simple, create the flowchart, enumerate naturally, get the successors, which also will have us directly get the basic block, which we can directly use start and end EA and so on. So, and here it is, we got the same results. Thank you for following through this a bit longer than the previous video, but this concludes our first work with flowcharts. Now there are a bit more advanced topics with respect to ranges. We'll leave that to another time. Thank you, and please like, share, and subscribe if you haven't. Thank you very much.